Hello, you are welcome to this session. It is session 4 of Unit 3 of PCK in Chemistry. And in this session, we are going to determine the relative molecular mass and relative atomic mass of a substance. The objectives for this session are to determine the molecular mass of molecules using titration, and then to determine the atomic mass of an atom using titration. So let's get going, and we are starting it with a problem where A is a solution of a dibasic acid containing 4.6 grams per decimeter cube of the acid, and B is a solution containing 2 grams of sodium hydroxide per 500 cubic centimeters of the solution. So I always prefer that you try to know the plan, how you are going to attack the problem at this point before you continue. So we have these two solutions, and looking at them carefully, it is very convenient to start the solution from B, where we have enough data as compared to the A. Mind you, in the A we only have the mass concentration. In the B too, there is mass concentration and there is volume, but in the A there is X that we don't know, and we'll suffer if we start from there. So we'll start from the B and we'll use relation to get to the A, which is the dibasic acid. This is the instruction for the titration, but then we are to find the concentration of A in moles per decimeter cubed. We have to find the molar mass of the dibasic acid HX, the atomic mass of X, the percentage of X in the acid, and we have been given the relative atomic masses as well as the average volume of A used. Okay, so let's look at our solution. The first task was to find the amount concentration of B. But in the question, we have been given enough data to find that. We have been given mass, which is 2 grams. We have been given the volume, which is 500 cubic centimeters. And we can find the molar mass, which is 40. So knowing these values, we just do our substitution into the relation concentration is equal to mass over molar mass times volume. And when we do that, we have the amount concentration to be 0.1 mole per cubic decimeters. Now, from there, if we were to use the other method, then we'll be interpreting the concentration as 1 mole or 1000 centimeters cubed containing 1 mole of the B. But here we are using a different approach and also see which one of them is simple. So we have the equation of reaction, which is sodium hydroxide reacting with the dibasic acid to give us NaX, and then water, the salt and the water. But we don't know the X, and so we have to find it. Now, from this equation, we can do our mole ratio. 2 moles of the base reacted with 1 mole of the acid to give us the salt and the water. So, moles of the base over moles of the acid is equivalent to 2 over 1. That is 2 of the sodium hydroxide as against 1 of the acid. But remember that amount N is also giving us concentration times volume, that is C times V. So we can now say that, or we are coming to do a substitution here. In place of the N, we are going to put the formula there. So the concentration of sodium hydroxide times the volume of sodium hydroxide over concentration of the acid times volume of the acid is equal to 2/1. We have not done anything strange here. We have only substituted the formula for N in place of N. Now, we have to look for values and put them here. But let's see. So, we have the concentration of the base to be 0.1. That is what we calculated. And then, in the question, we're given the volume of the base. That is the pipette volume, which is 25, over concentration of the acid is what we are looking for, times the volume of the acid, which is the average titer, or the volume that we used from the burette, which is 26.5, is still equal to the mole ratio, which is 2:1. So what is left is to just make concentration of the acid the subject, and that gives us 0.047 moles per cubic decimeters. So this is not the first principle. The first principle is what we've used in the previous sessions, but this is also a method that works well, and it is simple. We will not have to be going to say if 1,000 of this contains that, then this volume will contain that. We can use this in place of that. Okay, so now we know the concentration of the acid to be 0.047 moles per cubic decimeters. Now, the second part was to find the molar mass. And to know the molar mass of the acid, we would have just used the relative atomic masses, but we don't know what X is. So we just have to use the relation from concentration and mass concentration, if you remember. So molar mass is given as mass concentration over amount concentration. Thankfully, we have the mass concentration in the question it was given, and the amount concentration is what we found to be 0.047. A substitution into the relation gives us 98 grams per mole. So that is the molar mass of the dibasic acid. Now that we know the molar mass of the dibasic acid, then we can find the relative atomic mass of X. We know that in finding molar mass, we use the atomic masses. So if we have calculated the molar mass to be 90, we just have to go and do that calculation and equate it to 98. So we have hydrogen, 2 atoms of hydrogen times the atomic mass of hydrogen, plus here the X is just 1. So let's say we don't know for X, let's put X there. So plus X is equal to 98. It means that X is 96. So the atomic mass of X is 98. I hope you have enjoyed this lesson so much. Now, the last part is to find the percentage of X in the acid. We know the mass of X in the acid, and we know the total mass. So we just divide the mass of X by the total mass, multiply by 100. That will give us 97.9%, and that is the mass, or that's the percentage of X in the dibasic acid. We end the session with some questions, and I urge you to try and solve them. We'll meet again in the next session.